Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, let's talk about where we're going with these 300B amplifier projects. And this is kind of a unique build that a customer emailed me saying, I want at least most of the goodness that you get from like your ultimate 300B build, but without the expensive chassis. And I get that there needs to be some sort of a kind of middle ground here between the base model that's going to have the musical power supplies, transformers, and like this ultimate deal with the select wood fancy chassis with the metal plates and all the ISO iron transformers, power transformer and everything. There needs to be something between. And so that's what we're attempting to do with this build. And we're using Hammond power transformer and choke. In the future, I would probably build one of these with the musical power supplies transformer with a Hammond choke to avoid having to put this big 266 L14 filament transformer in it. I wish they made a 2 amp one and they don't. They make this 4 amp one and it's so big you can see I had to kind of trim this little piece of plastic here off and glue these wires down and angle mount it to get it to fit within this 2-inch chassis. I guess in the future I could have used a 3-inch chassis, but to me with the metal in this black it looks too chunky. When you do the thick one, I built my first KT88 one with a 3-inch chassis, and I just never really cared for the way it looks. And I know, it's supposed to be about the sound, but most people are going to put one of these amps out in a prominent position in their living room or, some other living space, and it looking nice is important too. So, we're using the FC30 3.5 S2, the champions of our output transformer shootout, and I'm trying to change up some of the wiring I did from the original one. I've learned a lot about power supply filtering, what's kind of mandatory, what is probably not audible and is expensive, and so we're doing a little bit different stuff on this one. We're still using a dual rail power supply after the first choke, like the original one, but instead of using a pair of chokes for the second stage of filtering, we're going to use resistors and caps. And that also allows us to put the caps really close to the output transformers, which I think is probably more important than having the chokes versus the resistors. And my 283 is perfectly silent using this type of power supply. So is my EL34, which are both designs I came up with after I did that initial 300B thing. And so, yeah, I'm learning as I go along. Trying to make the wiring cleaner and shorter signal path is one of the keys. And again, I've kind of learned some layout techniques from my 2A3 that I think can be applied to this 300B that's just going to make it not only shorter signal path and hopefully a cleaner sounding amp, but something that you guys can easily replicate. And also on my original one, looking through it, I was kind of used a hodgepodge of resistors that I just had around, and I was not thinking that resistors were audible at that point. And I've learned since then they definitely are. And so we're going to be building this with these Vichy PRO metal film resistors for most of the amp, but we're going to be using a carbon film for the grid leak resistor for the 300B tube, because I found that little tweak really helped my 2A3. Audio note, caps on the cathode resistors. And anyway, I'll go into a little more detail in the middle part of this video, so let me get on showing you that. So I'm going to go over how I've changed some of the wiring from my original 300B layout to this one that I'm building currently for a customer. And Before I had used two smaller 6.3 volt single winding filament transformers along this area in here. And this time we went with this 266L14. I wanted to bump the voltage up just a little bit over the 6.3 because I feel like that it didn't quite have enough headroom on these LDO regulators. And while the tube was warming up, they would drop out a little bit, and this solved that problem going to 7 volts AC into these rectifiers in the back that I'll show you here in a minute. So one of the things that I've worked out with Matt at Musical Power Supplies is he's custom wound the Skunky 300B power transformer that has two 7 volt windings and a 6.3 volt and a 5 volt all in the same transformer, so we can eliminate this filament transformer. And we're going to be doing our standard 300B builds with that from now on. But I still had some of these filament transformers and Hammond power transformers that, perfectly serviceable, so I wanted to go ahead and use them in this amp. But as I showed you in the earlier segment, you could see how I had to angle mount this, and it just was a kind of a struggle to get it to fit in this 2-inch thick chassis. And again, when we do the Musical Power Supplies power transformer, we'll be able to eliminate this, which means then we can move this 22 UF, and actually in this one I'm using a 27 UF filter cap. We can move it back here to the back of the amp where I did it on my 2A3, and put the star ground point back here, and it'll just simplify this side of the amp. So this is probably going to be kind of a one-off the way this was wired, but from these regulators for the DC filaments for the 300B tube and all of this wiring is going to stay the same. So I'll show you this rectifier setup in a minute, but for now, this is the DC coming out of these rectifier bridge setup here with the filter, and it comes down this green wire. We have one LDO regulator here that regulates this to 5 volts, and then let me zoom in here and show you this a little more in detail. Okay, so we got our DC coming in here. We got these tantalum capacitors. We got a 10 UF on the input, 22 on the output, and then we have the DC 5 volts coming off this LDO regulator up here to the filaments. And then the green is the negative and the white is the positive 5 volts. It comes over to this little tag strip here. Move this out of the way so we can kind of see this a little better. And you can see we have a couple of these 50 ohm wire wound resistors that go from each side of the filament to this virtual center tap we've created for the cathode of the output tube. In the original one, we used a potentiometer, but I realized that it always runs in the center, and so there was no reason to have that adjustable pot with DC filaments. And so we just went with some non-inductive wire wound resistors instead, which I think are probably going to sound better. And then up here in the front, this is the grid stopper 100 ohm. This is the positive lead that comes off of the output transformer to the plate of the output tube. This is our carbon film grid leak resistor. We have this ground wire that comes over and shares this ground point. So it runs to the lower point of this tag strip. It's kind of hard to see here. Let me tilt the amp up. So you can see this lead here goes through the chassis. It's also a ground, and it goes up to the cathode resistor that's on the top of the amp. And then that is also the ground for the bypass cap. And then this terminal here is the signal off the center tap of the cathode. So it comes over here, and then it goes down to the top of the amp through this wire right here, goes down through this grommet, and is the other end of the cathode resistor that's on the top of the amp, which I'll show you in a minute. Now, when I was originally wiring this thing up, I had this tag strip down here on this bolt and went over and across, and I realized that then this lead here, instead of just jumping across real short like this, was going to have to like go across the wire that was going to the grid of the tube, and was going to be a lot longer wire. And again, trying to keep the signal path short, I moved the tag strip from here to the back because it didn't make the heater wires any longer. And then the center tap of the virtual center tap, which is between these two 50 ohm resistors, it's a lot shorter path over here to the cathode resistor and the bypass cap. So then let's look at this little area right here, which is a change from the earlier amp. I had all of this stuff mounted like way over here, and I wanted to get it closer to the output transformers. And so let me scoot this over a little bit here. There we go. So this big white wire here, and this is a piece of 14 gauge Romex coming over from the filter cap area in the front of the amp. It's coming down here to these two resistors, which are 50 ohm 5 waters, that are the second stage of filtering, the RC filter for the output transformers, or the output stage of the amp. And then these connect, the Romex connects between these two terminals, and then the other side's connected here and here, which then have these white wires that come over here to the B plus terminal on the output transformers, and this is the red wire that come up and over to the plate of the output tube. Over here we have the voltage divider that lifts the center tap of the 6.3 volts that go to the front end tubes. Because it's a cascode, we need to raise the heater voltage to about, it's not super critical, anywhere between 40 and 50 volts is fine. I think 45 volts is what this one ended up being. And then the value of this cap isn't even super important. This is a 47 UF 160. You could even go down to probably a 10 UF would be fine. And as long as it's like 63 volts or up, is probably big enough. I just happen to have a batch of those things, so we use that one there. And we pull the voltage for this voltage divider network off of this side of this resistor. You don't want to pull it off that side. You want to pull it off the B plus side. So that lifts the center tap of the 6.3 volt. You can see we've got these big 100 UF 500 volt caps up here next to each other. These are the filtering caps for the second stage of the voltage supply for the output transformers. And having these right here next to the output transformers, I think is just a good idea. Here we have this ground wire, which is this black wire that comes over to the front end ground point, or the star ground point, and then these two terminals are grounds. They're tied together with a strap of wire between them, and then this is the ground that goes over to the voltage divider for the 6.3 volts. You have this ground wire just zips over here and ties to this tag strip, and that gives you the ground for the cathode and the cathode bypass cap, and also is the ground point that comes over to the grid, loops under this cap over to this terminal, and there's our grid leak resistor. That this is where the output of the front end, or the driver tubes, connects with the coupling cap. And the same thing over here. got the ground, comes over, connects up through this resistor, which is the grid leak, which is a little 220K carbon film, and that references the grid to ground, which is necessary to bias the tube. And I think having all of this just like in this little package like this has really tightened up the whole layout. And I like the way these just have these little short jumpers over here, jumper over here. And the other thing I do intentionally with my 300B amps is the output tube sockets are wired in reverse polarity. And again, this is the positive, this is the ground. You spin the tube around and then it's reversed. And then this is the ground and that's the positive. And the reason you do that is DC heaters can make one end of the filament get used up faster than the other. And by rotating the tubes from one socket to the other every few months, it just maximizes the life of the tube without you having to do anything except just rotate the tubes. So that's kind of a little feature that I like doing on my direct heated DC filament amplifiers so that the tubes wear evenly. And that's kind of it for the output section of the amp. I still got to wire up the front end of the amp, so we haven't done that yet. That'll be in the next video segment. And I'll flip the amp over real quick and show you what the top side looks like so you understand what these wires going through these grommets are doing. And again, this is the positive side of the cathode resistor, and then this is the ground side that connects to this ground point. And then this one connects to here that goes over to the tube cathode. And then we have this bypass cap that goes positive, negative, that bypasses the resistor that I'm fixing to show you. But before I do that, let me show you what these rectifier bridge setup on the back of the amp looks like. And I may have to show you on my next build more in detail how to build this little thing out. But you have the AC voltage comes onto these two pins. The DC comes off the top and the bottom. This cap goes across it. Underneath here, it's kind of hard to see. There's a 4-leg bridge rectifier that's got heat sink or heat soak compound mounting it to the back of the chassis. And the same bolt that holds the tag strip down goes through the center of this bridge rectifier. And we have two of them, one for each tube. And again, when we do our next amp, I'm going to do a very detailed build of the standard 300B when we do that. And I'll go through how to build these little guys up and get them mounted. And then finally, this is what the top side of the amp looks like. We have our cathode resistors mounted here on the top between the two tube sockets. And the wires go through grommets to the inside of those tag strips that I just showed you. I like putting these on the top exposed like this so you keep the heat out from inside the chassis. This is like one of the hottest components in the amp are these cathode resistors. And I know some people don't like this. You can mount them on the inside if you want with some thermal compound and just go, hey, I'm going to do it like that. I think mounting them on the top like this lets them vent a lot better. It keeps the heat away from the other components, and it does transfer some of the heat to the chassis, but most of it goes out to the air. I think being between the tubes like this, it's a safe place for it to be. And then I put this liquid electrical tape over the solder connections on each end of them so they are insulated. They don't have super high voltage on them. I mean, it would probably shock you pretty good if you worked your way through this insulation to the wire. But I think having this liquid electrical tape on them, and then again being between the tubes, they're not somewhere where prying fingers would end up touching them. I think it's around 75 volts. And yeah, it probably still would shock you pretty good, but I don't think it's dangerous like having 500 volts of B plus on the top of the chassis would be. So that's the way we're doing that. And again, on the 2A3, we had the different style resistors. We had a vent hole right here, but on the 300Bs, the resistors are getting mounted on the top. So I think that's a good place to wrap up this video. We'll come back and go over the front end wiring in the next segment. Well, I hope this was helpful, kind of showing you my thought process on how I laid out the inside wiring of this new version of my 300B. And since this is a later version build of this same circuit, this is what I would defer people to building it like. I mean, I know a lot of people have built it like I did my first one, and in the next video, once I get the front end tubes all wired up, I'll show you like the whole inside of this one versus the whole inside of the other one. And I think you'll agree this one is less complex and easier to build. What's going to be even simpler is when we're using the musical power supplies power transformer and get rid of this big internal filament transformer. We don't have to deal with that mess. And again, I would recommend getting a 3-inch tall chassis if you're going to use one of these. What I did here works, but it was a lot of work. And it's really squeezing this thing into this slimmer chassis. And I hate to say it, a lot of people may not be able to do, reshaping the tangs or the tabs on the transformer to get it mounted at this angle. And don't do what I'm doing here. But this is going to work great for this customer's amp. And I'm really excited to hear what this sounds like compared to my earlier version that had different resistors. This one's also got a lot of silver wire in it. And so, it could have a different sound, which will be fun. They both have these same, high-end audio note cathode bypass caps, which is very important. And Solene caps, which we've talked about before, the power supply. So I think this is a good segue to end this video. Thanks to all you folks that subscribe to the channel. Thanks to you folks that join my Patreon and otherwise contribute to the channel. Thanks to you folks that buy stuff from me, because it allows me to build content for the channel like this to show you guys how to build cool amplifiers. So until the next video, have a nice day.